Greetings, Mr. Sutton here, bringing you the Pre-Cal Honors 3-1 Extra Practice Number 2 solutions on simplifying rational expressions. To simplify this one, let's start by factoring the numerator to see if there's any common factors that could cancel with this x minus 2. So I'll leave the x minus 2 down there, and up top it looks like I can actually factor out a 9 and an x from all that. That leaves me with an x minus 2 inside. And conveniently, these x minus 2's cancel, leaving me with just a 9x in the numerator, 1 in the denominator, but we can just write that as 9x. For this one, let's begin the problem by factoring to see if there's any common factors. So we can leave the n minus 3 where it is, nothing really going on down there, but in the numerator, we need factors of 15 that add up to negative 8. So there's 1 and 15, 3 and 5 would work if they were both negative. So n minus 3, n minus 5, and then these n minus 3's cancel, so that just leaves us with n minus 5 when all is said and done. To make any progress on this problem, we're going to have to start by factoring. So let me take a look in my numerator here, see what I can factor out of this one. It looks like I can take out a 5 and a v squared. So that's going to leave me with a v plus 5. And now in the denominator, I could probably factor that a little bit more. So I need factors of negative 5 that add up to 4. Well, let's see. The only options are either 1 and negative 5 or negative 1 and positive 5. Negative 1 and positive 5 would give us positive 4 if we added those together. So I'm going to go with v minus 1, v plus 5. And then these v plus 5s cancel completely because those are the same factor. So then we end up with 5v squared in the numerator over v minus 1. To simplify this problem, we can start by factoring that denominator. So I'll leave the numerator the way it is. And down below now, I can factor out a 9 from both of those, and also an x. They all have at least an x. So taking out 9x from 9x squared gives me x. And 81x divided by 9x, that's going to be a plus 9 in there. Can't do anything with that plus 9, x plus 9. But the 9x and the 3x can interact a little bit. The 3 and the 9 can reduce to 1 over 3, and the x's cancel completely. So then, since I've crossed off everything in the numerator, I still have that invisible 1 left over there. And down below now, I have a 3 parentheses x plus 9. For this problem, since there's no way to really factor this, all we can do is try to reduce it. Let's start with the 72 and the 45. We can definitely reduce those since they are both multiples of 9. So this can reduce to 8 over 5, reducing that by 9. And then the a's, those are the same base, so those can reduce. Subtracting my exponents, 4 minus 3, I end up with a to the first power in the denominator, because that's where the bigger exponent was. So let's see what's left over. In the numerator, all that's left is an 8. And in the denominator, we have a 5 times the a that was left over there, so 5a. For simplifying this problem, we're going to need to do a whole lot of factoring to start things off. Let me start with the numerator here. It looks like I can take out a common factor. These are all divisible by n, because they all have at least n to the first power. And also, it looks like 3. 3 goes into 3, obviously, and 45. And 162 also, because 162, those digits add up to 9, which is divisible by 3. That little divisibility by 3 trick, right? Every now and then comes in handy. So if I take out a 3n, and I'll leave the denominator the way it is, taking out a 3n in the numerator, that leaves me with n squared minus, this is going to be 15n, plus, well, let's see, what is 162 divided by 3? Well, 150 divided by 3 is going to be 50. This is 12 more than that, so it'd be 4 more after you divide. So 54 then, plus 54. And we can factor a little bit more. Let me bring down that 3n so I don't lose it. And now I need factors of 54 that add up to negative 15. Well, let's see, there's 1 and 54. That's not working. 2 and 27. That's not going to work. 3 and 18. Well, that would work if they were opposite signs, but they have to be the same sign because they multiply to a positive. 4 doesn't go into that, neither does 5. 6 times 9 is 54, and if I add them, that adds up to 15 if they're both negative. So we can write then n minus 6 and n minus 9. Okay, Well, that took a little bit of work. Let's factor the denominator now. Factors of negative 60 that add up to 4. There's 1 and 60, 2 and 30, 3 and 20. None of this is working. 4 and 15 doesn't work. 5 and 12, nope. 6 and 10. If I have negative 6 and positive 10, that adds up to 4. So we have n minus 6 and n plus 10. The only factor that we have in common is this n minus 6, so let's cross those off. And now in the numerator, we've got a 3n parentheses n minus 9. And in the denominator, we have n plus 10. And it's not going to get any better than that. To simplify this rational expression, let me start by factoring to look for common factors that I can cancel. So in the numerator now, I need factors of negative 7 that add up to negative 6. So we only have 1 and negative 7 that could make that work. So we have x plus 1 and x minus 7. In the denominator, I need factors of 9 that add up to 10. Hey, how about positive 1 and positive 9? So x plus 1 and x plus 9. X plus 1's cancel. Nothing else does. So we're left with x minus 7 over x plus 9.